Hello, so this is the last video in my Algebra 2 series, and today we'll be learning all about trigonometry. I will assume that those of you who are listening have already gone over basic trigonometry, so like SOHCAHTOA, and then like cosecant, secant, cotangent, and have been at least introduced to the main ideas of this chapter, because these are mainly problem working videos, not full lessons. But there'll be a little bit of lesson stuff in here. But yeah, let's just start with trig. The first thing that you'll probably need to know is that a lot of the time we measure angles in degrees. However, from this point forward in math, a lot of the times, angles are not represented in degrees, and they're actually represented in something called radians. You can convert to radians by multiplying by pi over 180. And essentially, radian is based off of the arc length of a circle, and it's kind of measuring the ratio of arc length to the radius of a circle. And that gives you an angle. That's the idea of a radian, and if you want to look more into it, you can look it up. But to convert from degrees to radians, this is how you do it. You just multiply by pi over 180. So simplifying, 10 pi over 18, 5 pi over 9. So 100 degrees in radians is 5 pi over 9. We can also convert from radians to degrees. So an angle, like pi over 8 in radians, instead of multiplying by pi over 180, we multiply it by 180 over pi. And basically, that becomes 22.5 degrees, or 180 over 8 degrees, if you want to keep in fractions. But yeah. Now that we've learned about radians, let's move on to doing some trig stuff. So, let's say for a problem like this, oops, sorry. Okay, so what does this tell us? Let's draw the triangle. Let's put theta here. It doesn't really matter where you put theta, but I like to put it there. So it's telling us cosine is 4 over 9, so adjacent over hypotenuse is 4 over 9. We can use the Pythagorean theorem to find the other side. And if you do that, you'll get square root 65. So now, all we have to do is just do our SOHCAHTOA, sine theta, 65 over 9. We already know cosine theta is equal to 4 over 9. Tangent theta is just equal to root 65 over 4. Now, to find the other three, we just flip everything. And I just rationalized the I rationalized the denominator because cosecant would be this, but then I just did this, just so you guys are aware. Oops, cotangent. And we're done. We didn't have to worry about negative stuff, but we will in a second. Well, actually, first I'm going to do something before we get there. Okay. Let's do a similar question. Now you're wondering, how do I find this? Well, pi over 2 in degrees is just 90 degrees, right? Now imagine this. If this is theta, then this is just 90 minus theta, right? So in other words, sine of this angle is just going to be cosine. So, boom. Because if you think about it, if I say ABC, if I say sine 90 minus theta, that's just S is equal to B over C, right? But cosine theta is just also B over C. So this guy is just cosine theta. Anyway, back to the problem. Tangent theta, so opposites over adjacent. So 5 over 1. And then Pythagorean theorem, this is 26, or root 26. So cosine, we're looking for cosine. So we're looking for this is technically correct, but your teacher will probably want this. Now, let's complicate things a little bit more. And the point will be -5, comma -12. Let's draw this in the coordinate system. This is the triangle we're dealing with. And the angle that we're dealing with is this. However, we're going to use the reference angle. The reference angle is just this guy. I'm going to call this theta. Oh yeah, I'm using Pythag. We know that this is 13. So now all we have to do, find the trig value. I apologize. Sine theta is equal to opposite over adjacent. Opposite over adjacent, really? Opposite over hypotenuse, I apologize again. That's tangent. Cosine is adjacent over hypotenuse. Now tangent is actually going to be positive because a negative over negative is going to be positive. And then for everything else, we just flip it. And we're done. That is all. Now I'm going to move on to the most important, probably most important thing, or parts of your trigonometry careers, and it's the unit circle. You guys probably know what the unit circle is. If your teacher hasn't gotten there, he better get there, or she better get there. Let's just do some unit circle stuff. Defines whole trig functions. $60 degrees. Okay. As you may notice, so 60 degrees. This is bigger. 3, this is a 30, 60, 90 triangle. So if you remember, and now what we have to do is find these values. Or you can memorize the unit circle. I find that to be very helpful. Then you just flip it. That is all. Now that was something in the first quadrant. Let's do something in the second quadrant. Make it a little bit more complicated. Let's do the angle. Let's do the angle 3 pi over 4. That's this. So sine in the second quadrant is positive. So if you memorize your 45 right triangle, this should be pretty easy. You should get this. Cosine's the same, except in the second quadrant's negative. Tangent is sine over cosine, but cosine's negative. Then we just flip everything. That's all. Now I'm going to do one more. This one might be a little bit tough. Find all trig values of this. Three pi over 2. Okay. Well, that's this guy. For each endpoint, so like 0, pi over 2, pi, 3 pi over 2, and 2 pi, back at 0 again, you should memorize the unit circle values for those. For sine 3 pi over 2, you'll notice that's negative, negative 1. There you go. Cosine 3 pi over 2, there's no x coordinate, so 0. Tangents 3 pi over 2. So because tangent is sine over cosine and cosine is equal to 0, this is undefined. Because negative 1 over 0 just doesn't work. Cosecant 3 pi over 2 is also negative 1. Secant 3 pi over 2 is equal to undefined, because if you flip it, you also get something over 0, and that's undefined. And then cotangents at 3 pi over 2 is actually not undefined, because cotangent is cosine over sine, so 0 over negative 1. So it's actually 0. Okay. Now I'm going to do something. We're going to go in reverse. We're going to do inverse trig. Instead of finding the sine of an angle, we're going to find what angle produces a sine value. I keep doing it, sorry. So how do we do this? What this is asking is, what angle, if you take the sine of it, will give you root 3 over 2? So, easiest thing here is either remember the trig function, or like memorize the unit circle, or draw the triangle. So, sine of some angle theta is going to give me root 3 over 2. So in other words, it's going to give me root 3 over 2, like this. And we know this is 1. Now, what angle could this possibly be? This is a 3, 4, 5 right triangle. You'll notice that this should be the 30-degree angle. So this should be pi over 6. because this is pi over 6, and then this is 30 degrees. This is pi over 3. So the answer is pi over 3. And we answer in radians, not degrees. I mean, degrees is also technically true, but your teacher might hate you. This is a little harder. Dude. Oh my gosh. Fine. Now, cosine of what angle will give me negative 1/2. So we know it has to be somewhere in the second quadrant. So honestly, the easiest thing, draw a triangle again. This is a 3, 4, 5 right triangle again. You'll notice, again, this is the 60-degree angle. But since this is in the second quadrant, it's not pi over 3. It's 2 pi over 3. Okay. Now, we're going to get a little bit more complicated, but still same idea. How in the world do we do this? So, start from the inside. If this little thing is theta, then let's draw it. So, this is a 3, 4, 5 right triangle. This is 4. Now, all it's asking for now is tangent. What's tangent? Opposite over adjacent. The answer is 2/4. We're done. Okay. One last lesson before we end. And it's an important one. How to graph trig functions. So in other words, how do you graph something like this? Well, first of all, there's a couple things that you want to know. So, a typical sine wave is going to be in this format. A is your amplitude. It's how big the wave is going to spike up. B is an important thing because it determines the period. The period is how many oscillations that are going to happen. So like, for example, sine repeats, right? So it's going to look like this, right? But this is one period because it just repeats again. This is another period. So let's identify each of the things. So A, what the heck? A is equal to 5. I'm talking about this guy, by the way. B is equal to 2. C equals negative pi. And D is equal to 0. We don't care about D right now. Anyway, I'll just show you how to do it. So, and by the way, the period of a sine function is always 2 pi over your B value. So let's just do it real quick. We know that's because of this, it's going to be shifted to the right by pi. So we're going to start this at pi. And the period is equal to pi. So we should be ending at 2 pi. Because 2 pi over b, 2 pi over 2 is equal to pi. And then we just split it up into increments of 4. So I would divide the period by 4, and then you'll see what I mean. So increments of pi over 4. Okay? And then because our amplitude is 5, it's going to go like this. Alright? So now all we do is this. This is the standard way of graphing one period of a sine function. Just like that. Pretty simple. You just gotta know the little parts, and then it all fits together nicely. Now, I'm going to do the same thing but for a cosine function. Cosine's a little bit different, but same main idea. Let's do positive cosine. Okay, let's graph this guy. So same idea, this is A, this is B, this is C, and D is equal to 0. Let's graph it. So important thing to note, period is equal to 4, yeah, because 2 pi over 2 should give us 4, yeah. Okay. Amplitude is equal to 2, right? And we have a shift to the left by 2. Damn. All right. So we're going to start this guy. Normally we would start at 0, but we're going to shift it by 2 to the left. And because our period is 4, we're going to end at 2. So the interesting thing with cosine is that it always, unless it's negative, like if it was negative here, cosine always starts at the top. So what do I mean? It will start at the amplitude. So now all you have to do is break it up in increments again of 4. 4 divided by 4 is 1, so increments of 1. So now all you have to do is this. And this is the period of one cosine graph. And then if you were to graph more, it would look like this. I'll show you what happens if it was negative. If it was negative, then all you do is you flip it. Oops. I meant to get rid of the dots. Okay. All you would do is you would start at -2. Then go here, then go here, then go here, and then here. So it would look like this instead. Same thing with sine. If it was positive sine, then it would look like this. If it was negative sine, then it would look like this. That's the only difference between positive and negative. But yeah, that's the main idea for trig. It shouldn't get too much more advanced than that. Pre-calc, you'll have to deal with more identities and whatnot, but that's the basic bare bones idea of trig. So yeah, that's it for my Algebra 2 series. Good luck. I know my videos are not full lessons, but I hope they at least helped. So yeah.